Thank you for joining me in today's class. I'm glad to have you here. Today I want us to look at the concept of graphical solution to rectilinear acceleration. In our previous videos, we discussed about how we can solve motion problems using the equations of motion. But today, I want us to look at a different way to solve the problems involved in motion. Now, if we want to solve such a problem, the VT graph or the velocity time graph is commonly used to solve the rectilinear problems. Okay, now we look at such a problem. If we have a graph like this is a velocity time graph. Now, for acceleration of a body, it's either the acceleration is increasing or it is constant or it is reducing. So these are the three major cases. Now, case one, if the acceleration is increasing, so if it is increasing from rest, if it is from rest, we have an increase in acceleration. Remember, this is a velocity time graph. That means here is V in meters per seconds. Here is T in seconds. Now, if the acceleration is increasing from rest, or if it increases uniformly from rest to a certain point, here is increase in velocity, increase in acceleration. Now, if at a point the acceleration becomes constant, that means it will now move like this. If peradventure the motion suddenly the driver sees a pothole or a parked vehicle, next thing is to apply brakes. Now, if you apply brakes, now this is the shape of the motion we have. Now, this shape explains the three cases. Case one, increase in acceleration. Case two, when the acceleration is constant, and case three, when the acceleration is reducing, that is retardation or deceleration. Now, because of this shape is called a trapezium. Now, from here we can have this point. If we bring it down or bring this point, automatically we now have two triangles and either a rectangle or a square, as the case may be. Now, with this we can calculate for distance. We can calculate distance covered. That is the first thing we can calculate here. We can as well calculate acceleration. And the third thing we can calculate here is deceleration or the retardation. Now, and of course, from here, assuming here is 0, let's say A, B, C, we have D here, and we have E here. Remember, this we can still trace this. Any value you have here is the value of your speed or the velocity, because this is a velocity time graph, and whatever you have here is your time, which is in seconds. Now, for the first one, if you want to calculate the total distance from the starting point to where the body applies is a brake or the body comes to rest, that is from O to C. Now, total distance will give us total distance covered. Total distance covered, we can say S is equal to half into, now since it's a trapezium that has a longer side and that has a shorter side, so we can have, we'll take the longer side first plus the shorter side times the height. Now, the longer side is OC plus the shorter side. It's either you take it as AB or you take it as ED. However, we can now take it as AB. Now, times the height. The height is either you say AE or EA or BD. That is the height. So we can now have AE. So this is the total distance covered. Now, in absence of total distance, assuming maybe from this point now, you can still have distance covered here. Distance covered here at this point, assuming we have 1, 2, 3, section 1, section 2, section 3. Instead of asking you total distance covered here, you can, someone can say ask you distance covered in either section 1 or distance covered in section 2 or distance covered in section 3. Now, if you want to take distance covered in section 2, it's just area of this rectangle, and of course, area of the rectangle now is for section 1. For section 1, distance covered there, distance is area of this triangle. Section 1, area of triangle, distance there is half base times height. And of course, half base times height will now give us distance is equal to half into the base. Now, this is the base. The base is either you say the base is ED times height of this, which is BD or AE. Half base times AE. Okay, that is for here. If it's for this one now, this for section 2. For section 2, we now have S is length times the breadth, because either we have it as a rectangle or a square. It is still length times the breadth. Now for section 3, it's still the same thing. Distance covered here, S is half base times height. The base here now is DC, half DC times height, which is the BD, as the case may be. Now, I have discussed 3 different cases, or 4. The first one, total distance. Second one, distance covered in this section. Next one, distance covered in this section. Next one, distance covered in this section. Now, if we are done with that one, the next one I want us to look at now is the acceleration. Now, acceleration now is only covered here because at this point, the acceleration there is uniform acceleration. Increase in speed. The speed increases here. So this is the only where we have acceleration. Now, the formula for acceleration here is the slope. Acceleration is the slope of first triangle, slope of triangle, which will now give us the slope is acceleration equals, this slope is changing whatever value you have here, changing the vertical axis, all about changing the horizontal axis. So we can now have here, since we don't have anything here, we can see trace it like this. This one we can see trace it like this. So we now have AE all over this side. So AE, which is this side, all over this side, which is we can have OE. So this is our slope for this. Now for the retardation, we now have the retardation is for retardation we have a slope of this triangle here, which will now give us the slope of a triangle, the second triangle, this triangle number 3. So which will now give us retardation is equal to the slope. Now we now have the BD all over. In this case now, we now have what you have here minus what you have here. Because if you do what you have here minus what you have here, you get positive. Because retardation is always negative. You say what you have here minus what you have here, you can say BC, as the case may be. So if we now take calculations, we can be able to understand some of these facts. Okay, let us take the first problem. But before that, we'll clean up. A body moving with uniform acceleration A has 2 points A and B. It has 2 points A 5, 15 and B is 20, 60. So these are the 2 points on a velocity time graph of its motion. Calculate the value of the acceleration. Calculate the value of the acceleration. Now, we said that on a velocity time graph, the motion of the body is just 2 points, A and the B. So in other words, what we have to do is to represent this motion. Now, if we represent it, this is V in meter per second. This is time in seconds. Now, we have these are 2 points. We plot it first. After plotting it, that is when we now calculate it. So you have to plot it. Well, this is X, this is Y. This is X, this is Y. Now, because this is the first one, we can now have it as X1, Y1. This one is X2, Y2. So we plot it. Now, the first one here is 0, 5, X1. Along this point here, Y1 will have 15. We'll have 15. We trace it. If we trace it here, this is where we plot. And now this is a point A. The second one, X2. X2 is 20. X2 is 20. We plot 20 here. Y2 is 60. We can plot 2 here. And then trace from here up to here. So we have this as our B. This is point B. Now all we need to do is to join those two lines. Now if we join those two lines, we have, we join those two lines, those 2 points, this is what we now have. Now the next thing we'll do, since they say calculate the acceleration, all we need to do is we fix in here, and now we will now have a triangle. Now since this is our triangle, we'll take the area of this, we'll take the slope of this triangle. So the acceleration A is the slope of triangle. Slope of the triangle. Now the triangle will have here slope, or the gradient is equal to y2 minus y1 all over x2 minus x1, which will give us y2. Remember this is our x1, this is our x2, this is our y1, this is our y2. So we pick these values. 60 minus 15 all over x2. x2 is 20 minus 5, which will give us, this minus this will give us 45 all over 15. And 45 over 15 will give us 3. Therefore, acceleration is 3 meters per second squared. Okay. Now we move to the next question. But before that, as our budge. Now we take the second question. That second question says, a car starts from rest at checkpoint A and comes to rest at next checkpoint B, 6 kilometers away in 3 minutes. It has first a uniform acceleration for 40 seconds, then a constant speed, and is brought to rest with a uniform retardation after 20 seconds. The first question says, sketch the velocity time graph of the motion. And the second one says, determine the maximum speed. Third one says, calculate the acceleration. And the fourth one says, calculate the retardation. So, having done this, we first represent the motion. Now, they said a car from the first checkpoint moves from rest to the next checkpoint and then apply its brake. So that is from point A to point B. Now, we have this as the motion, the velocity time graph, V in meters per second, T in seconds. Now, this body moves from point A. Now, let's say from point A, this is a point A here. It moves Remember, they say initially it has acceleration up to a point, it stopped and then maintained a constant acceleration. On getting to a particular point, it applied its brakes. Remember, from the question, they says that B, this is checkpoint B. This checkpoint is 6 kilometers. The distance between point A and point B is 6 kilometers. So distance of A and B is 6 kilometers. And of course, we need to convert this distance. So distance S, which is 6 kilometers, 6 kilometers, if you convert it, of course, kilo means 1,000. So once you multiply by 1,000, you'll get that our distance is 6,000 meters. Remember, the question says it took the car to move from point A to point B 3 minutes. Now, time is 3 minutes. And these 3 minutes, you need to convert it, because this one is in meter per second, this time is second. You convert it to seconds. For convert it to seconds, it will now give us 3 times 60, which will give us 180 seconds. So the time taken for the body to move from here to this point is 180 seconds. Distance covered also is 6,000 meters. Now we bring this one down. So we'll still continue. They said it has first acceleration A for 40 seconds. That means the first acceleration lasted for 40 seconds. That means here is 40. Then a constant speed, and it's brought to rest with a uniform retardation after 20 seconds. Now, after 20 seconds, remember they gave us time, the acceleration took place for 40 seconds. Now they gave us the total time. Now they said it was brought to rest after 20 seconds. Now 180 minus 20 will give us 160. So that's how we'll get this one here. Okay, now the next one says, okay, it is done now. They say calculate the first one. The first one says sketch the diagram of the motion. This is this diagram of the motion. Remember, they didn't give us V, so we need to find V. This V here is not given. So that is the second question they asked us to get. They said maximum speed. So this is the maximum speed or the maximum velocity attainable. Now, how do we get this speed here? And of course, recall that our formula says distance is equal to half what you have here. Assuming since we have here A and B, you can have a B. So you can have a C here, we can have a D here, we can have E here, and we can have F here. So having labeled it like this, so when I recall that we said that the total distance is what you have here, AB plus the shorter distance, which is a BC, multiplied by height, which is a DF. Now, for us to use this is the total distance covered. Remember, they gave us the total distance. Total distance covered is 6,000 meters. So we will now use it because we cannot calculate this one. Remember, this one is our height. If we trace this up to here, this is the height. That means to get this, we will multiply by the height, since the height is what we're looking for. So let us substitute. So total distance covered is 6,000. So we have 6,000 is equal to half into the longer side is 180 plus the shorter side. The shorter side is distance from here to here, and of course this is 160 minus 40 will give us 120. Multiplied by the height. The height is DF, which is this V we're looking for. DF. Now we have 6,000 is equal to half into 180 plus 120 will give us 300. 300 times df, which will give us 6,000 into, of course, half times 300 is 150. 150 times this will now give us 150 df. Now df will give us 6,000 all over 150, which will give us 600 over 150 will give us from our calculator 600 over 15, please. 600 over 15 will give us 40 meters per second. So that is our speed. So the speed, the velocity is 40 meters per second. Now we take the next question. The next question says, question I, acceleration. In order to calculate for our acceleration, I'm sorry, I will use this side. Acceleration is equal to slope of this triangle. This slope of this triangle, the slope of AD, slope of AD. Slope of AD will give us, now what we have here minus what we have here. So having gotten here, we now have this value, have it to be 40. So we have 40 minus 0. So this minus this here is 0. So 40 minus 0 all over, we have 40 minus 0, which will give us 40 minus 0. 40 minus 0 will give us, well, we'll cancel this. If we cancel this, we have 1. Therefore, our acceleration is 1 meters per second squared. Okay, we move down to the second question. The last but not the least says the retardation. Now, for the retardation, we have slope. So retardation is slope of D is BC or CB, as the case may be. So which will give us that it is the height now minus this height, which is the EC all over BE, and which will give us here the height. If you trace it is 40, based on what we got earlier. 40 minus what we have here, if we trace it down to give you 0 all over this side. Now, like I told you earlier, you can, if you say 180 minus this, will give you positive answer. So what you have here, E minus B, 160 minus 180, 160 minus 180, it will give us that the retardation is 40 all over. 160 minus 180 will give us minus 20. And of course, we have 2 will cancel, 0 will cancel 0, 2 will cancel this. So give us 1 over 2. And of course, 1 over 2 will give us that the retardation is minus 0.5 meters per second squared. So this is the final answer. Okay, now we'll move to the next question. And the question says, if a car starts from rest and moves with a uniform acceleration of 10 meters per second squared for 10 seconds, the distance it covers in the last 1 second of its motion is dash. The distance covered in the last 1 second of its motion. Now, to solve this problem, we now have that since the body started from rest, U is 0, V is unknown. Now, acceleration is 10 meters per second squared. Time taken for that acceleration to be completed is 10 seconds. Now, the first thing we do is to draw the VT graph. This is velocity time graph in meters per second t. Now the body moves from rest. Since it moves from rest, the acceleration from rest. Now up to a particular point, 10. This is t. So assuming we have 10 here. Now the time taken is 10. Sorry, here I will put 10 here. Now distance covered in the last 1 second. Last 1 second is distance between the 10th second and the distance between the distance between the 10th second and that of the 9th second. Now at 10th second there is no v, so v will now give us u plus at. U is 0 plus acceleration is 10 times time, which is a time. Therefore v will give us 100 meters per second. So in other words, we now come back to this bit. Now in the 10th second, v is 100. Now remember, we said the distance covered in the last 1 minute is the distance between the 10th second and, so if you subtract 1 from this, we now have 9. So of course if we have 9 here, we can trace this one up. If we trace it up, we'll trace this one here. Now for that of 9, when the time, in fact, we have the last 1 second, v at 1 second is what? V at t 1 second. So which will now give us v is equal to u plus a is 10 times t. T is 1, which will give us 10. So the velocity reached at 1 second is 10. Therefore, if we subtract 10 from here, we are going to have 90. Now this 90 will give us, if we trace it up to here where it touches the line, we have 9 here. So we are going to find this is where to find the distance at 1 second. So when I say distance covered in the last 1 second is the difference between the 10th second, between the 10th second and the preceding one, which is 9th second. Now, which will now give us area of these, assuming we have, these are 2 points B. So if we have here, now have area of this one plus area of this one, which will now give us this area of this triangle here. Of course, this is a triangle here, and this one also is a triangle. So area of triangle, the first triangle here, will give us half base. The base here is 10 times height. Height here is 100, which will now give us now minus half base. The base here is 9 times 90, which will now give us that 10 times 100 divided by 2 will give us 500 minus 9 times 90 divided by 2 will give us 405. Now if you subtract them, you now have 500 minus 405 will give us 95. So therefore, distance covered in the last 1 minute, the last 1 second is 95 meters. Okay, now this is where we bring the lesson to an end. Thank you for being there with me. Please, if you have not subscribed to this channel, do well to hit the subscribe button. If this lesson was helpful to you, please give it a thumbs up till we meet in our next episode. Thank you very much.